Hi guys, welcome back. We're doing chapter 20 today. Chapter 20 will cover the respiratory system and the excretory system, but today we're just going to concentrate on the respiratory system. Okay? So the main function of that respiratory system is to bring oxygen in to your body and to remove carbon dioxide from your body. Carbon dioxide is a byproduct of the chemical reactions taking place in your body, and you need to get rid of it. It's a waste product. Okay? Now, the air we breathe is only 21% oxygen. So most of what we're inhaling, we just exhale right back out. It's like 78% nitrogen, and we just don't use that. When you exhale, you're still exhaling about 16% oxygen, which is why something like mouth-to-mouth resuscitation works, because you still actually have some oxygen when you exhale, but a lot more carbon dioxide. All right, so your respiratory system works with your digestive system and your circulatory system to provide energy for your cells. I don't know if you remember really early on in the year, we talked about glucose, okay, and this process of cellular respiration, okay. Well, your digestive system breaks down the food you eat and gives that glucose to your cells, okay. But that glucose cannot be broken down or converted into energy by cellular respiration unless there's oxygen present. Remember, it's kind of the opposite of photosynthesis. Photosynthesis produces oxygen. Cellular respiration requires oxygen. So our respiratory system brings that oxygen in, our circulatory system transports those materials to the cells that need it, and then that process takes place, okay? So breathing is the process of moving air in and out. Respiration, for our purposes, we're gonna concentrate on, let me get my pen here. We're gonna concentrate on internal respiration. That's that cellular respiration. External respiration is the same thing as breathing, okay? But if you see the word respiration in this chapter, it's probably talking about that cellular respiration. All right, so got a pathway here. Let me move myself so you can see all the parts. There we go. This is the pathway of air, okay? When you inhale, the air is either going to enter through your mouth or your nose, depending on if you're a mouth breather from Stranger Things or not. Then it moves to your pharynx. Your pharynx is really just the back of your throat, okay? Just right behind your tongue, okay? Right below that is your larynx. That's where your Adam's apple is, and that's your voice box. We'll talk about that more at the end. Then finally you get into the trachea, okay? The trachea is your windpipe. It's a very rigid tube. It's surrounded by rings of cartilage to keep it from collapsing, okay? And that's why it hurts if you push too hard on your neck here, on your throat, because it's protecting your airway. Then it gets into the bronchi. This first branch right here into each of the lungs is your primary bronchi. Branches again, that's your secondary bronchi. Branches a third time, that's your tertiary bronchi. And then we start calling the additional branches bronchioles, okay? You can think of the little tiny twigs on a tree, very, very far out from the trunk. Those are the bronchioles, okay, much smaller. And at the end of each of those is an alveolus. That's singular for alveoli, and that's where the gas exchange takes place. When you inhale the oxygen, it goes to alveoli, trades place with carbon dioxide, and then when you exhale, you're letting the carbon dioxide out, okay? We'll talk about that gas exchange in more detail in a minute. All right, let's get back to this. All right. Your nose has a function besides, I don't know, just looking funny on your face. It actually filters, warms, and moistens the air as you inhale it. And if you look at this cross-section here, there's a lot of space up here. This nasal cavity, that's your sinuses. There's a lot of space, okay? So the air goes through there. There's a lot of blood flow in there. That's why we get bloody noses every once in a while, and that helps warm the air. There's a lot of moisture in there. And there's mucus, okay? That's where boogers come from. So your nose also produces mucus, which helps trap any dust particles or any virus or bacteria that you might inhale. It doesn't always trap all of it. Sometimes we get sick by inhaling that stuff. But for the most part, that mucus actually gets pushed down into your esophagus and into your stomach, okay? And it's helped by these things called cilia. And they're tiny microscopic hair-like projections that just kind of sweep that mucus down your throat. This is not the nose hairs that old men have hanging out of their noses, okay? This is like microscopic stuff. And the reason it's good to, and I'm not talking about like hacking loogies and swallowing that. I'm not talking about that. I'm talking about just normal stuff being swept down your throat. The reason that's okay is because your stomach has stomach acid in it, and it actually can kill all that bad stuff that you don't want in your body. And so God designed these little projections to pass it on down into your esophagus. Pretty cool. All right, let's talk about the actual gas exchange now, okay? Takes place in these alveoli, and you have something like 300 million of them in your lungs. So there's tons and tons of this going on, okay? Every single alveoli is surrounded by capillaries, okay? Because we're working with the circulatory system right here. We inhale, that gas needs to get into the circulatory system and out of the circulatory system so that we can exhale again, okay? So what's happening is the deoxygenated blood from the heart, so these blue capillaries are coming in, that pulmonary artery is bringing that deoxygenated blood from the heart. It's branching off into these smaller little capillaries. It has a very low concentration of oxygen, okay? But it has a very high concentration of carbon dioxide. When you inhale that oxygen, so there's a very high concentration of oxygen inside the alveoli here, okay? So that oxygen diffuses from the alveoli into the circulatory system, okay? Remember, diffusion is the process of something from a high concentration moving to a low concentration. So we have a really high concentration of oxygen, so it diffuses into these blood vessels, okay? That then goes to these red capillaries. Remember, red means oxygenated. That pulmonary vein will take that oxygenated blood back to the heart and pump it to the rest of the body, okay? Well, I mentioned that carbon dioxide as well. So these blue ones might have very little oxygen, but they have a lot of carbon dioxide, okay? So that high concentration of carbon dioxide is going to diffuse into the alveoli, because there's a very low concentration of it there. So they're trading places. High concentration of oxygen leaves the alveoli, high concentration of carbon dioxide in the blood goes into the alveoli, and then you exhale and you get rid of it. So awesome. All right, how do we breathe? How do we get that air into and out of our lungs? All right, well, we have this muscle called the diaphragm. So here's my buddy Bob, okay? You can see the diaphragm here, and it actually is right underneath his lungs, okay? And it's a muscle. If you ever get the hiccups, it's actually a spasm of that muscle, okay? And it pulls down, and I'll explain what's happening in just a second. So the diaphragm separates our chest cavity from our abdominal cavity. It goes all the way from the front and the back, okay? When you inhale, that diaphragm contracts and it moves down, and your ribs actually move out, okay? So what you've done is you've created a much larger space inside. It's not moving out because you're filling it with air. It's moving out so that the air can come in, okay? So by creating that higher volume, you're creating a lower pressure environment. The air has more room to spread out. Well, the higher pressure outside wants to get into that low pressure, and so the air actually pushes into your lungs. The air is not getting sucked into your lungs because science doesn't suck. It's getting pushed in, okay? And I'll prove it to you here. So I've got this cute little bottle here. Let me try to make myself a little bit bigger for you. Okay, that's good. The red balloon represents the diaphragm, and there's this little blue balloon inside. Okay, now watch what happens to the blue balloon as I pull down on the diaphragm. So when I pull down on the diaphragm, I'm creating more space. See that? That balloon actually filled up. When the diaphragm relaxes, it pushes the air out of the blue balloon. The blue balloon is like the lungs, okay? So by creating an extra space around the lungs, the air can spread out inside the lungs, okay? We actually draw additional air in from the outside. It gets pushed in, it doesn't suck, okay? So the diaphragm moves down, lungs fill up, diaphragm moves up, and the air gets pushed out. Whoa, I pushed too hard. You don't want to exhale too hard. Okay, let me make myself smaller again. Get out of the way. All right, and then that brings us to exhaling here. That diaphragm just simply relaxes and moves up. Those chest muscles relax, and it kind of squeezes the air out, and the air gets pushed out, okay? Kind of complicated, but it's much It's a lot more complicated than just sucking air in and pushing air out. Okay, it's kind of creating a vacuum inside of your chest, and that air gets pushed in. All right, now let's talk about talking. You have these vocal cords inside your larynx. So if you feel, as you're talking, you can kind of feel something moving up and down. Boys, if you're already going through puberty, your Adam's apple is going to start to stick out a little bit. That's your larynx. That's where your vocal cords are. Okay. And while you're singing or talking, you're constantly exhaling. You're pushing air over those vocal cords, and it causes a vibration. Okay. So just like you can make different sounds with a balloon, by changing the opening size, really high pitch, really deep, okay? The size of your vocal cords, the length of your vocal cords changes the sound of your voice. The longer the cord, the deeper. So the balloon, I stretched it more. I opened that opening quite a bit longer, and it became deeper. So in general, men have deeper voices because they have longer vocal cords. When I had that really high-pitched noise, I only opened it up a little bit. The vocal cords were very short, okay? And so shorter vocal cords means a higher voice. So typically that's why women have higher voices, because men get that much more pronounced Adam's apple during puberty or after puberty. And that means they have longer vocal cords. Now you can change that. You can stretch your vocal cords and alter your voice with singing and with speaking, la la la. Try it yourself and you'll feel a lot of movement actually taking place in there, okay? I believe that's all for today. Talk to you guys later.